Problem number 7. First of all, we're going to find the domain. The domain is all real numbers except for what makes the denominator 0. So x can't be 0, x can't be negative 4. So we say, therefore, the domain is all real numbers x, such that x cannot equal 0 and x cannot equal negative 4. So it's whatever causes the denominator to be 0. And then the range, we're going to get back to that after we check our horizontal asymptote and after we actually draw the graph. And then what was the next thing? Oh, we have already, so the second thing is to reduce the fraction. The fraction's already been reduced. So the third thing is, what are the x-intercepts? And what, if any, is the y-intercept? And so the x-intercepts are when whatever causes the numerator to be equal to 0. So if x plus 1 is equal to 0, then x equals negative 1. Therefore, the x-intercept, the only x-intercept is negative 1, 0. The y-intercept is when you let x equal 0. Well, notice that if you let x equal 0, you get r of 0 is equal to 0 plus 1 over 0 times 4. Okay, well that's 1 over 0. That does not exist. That's undefined. So therefore, there are no no y-intercepts. Well, how is that possible? Well, we'll check that out when we get down to the vertical asymptote, because that is next. So the next thing is the vertical asymptote. So vertical asymptote, just ha and va, whatever causes the denominator to be equal to 0. So x equals 0 and x equals negative 4. Well, that explains it. If x equals 0, that is the y-axis. And so if x equals 0 is a vertical asymptote, then the graph never crosses the y-axis. Likewise, to find our, well, kind of likewise, but horizontal asymptote is what we find when we're looking at the degree. So we're looking at the degree of the numerator and denominator. We have bigger bubble on the bottom, so therefore, we would say, therefore, the horizontal asymptote is y is equal to 0. So the x-axis, that's the x-axis, and the y-axis, right there's the y-axis, are asymptotes, as well as the x equals negative 4. And let's go ahead and, the range, let's do that after we actually graph, because I might start getting into some a little bit more complicated graphs. And let's do that, so maybe we can see the whole thing here. So we have y-axis, x-axis. Our y-axis is a vertical asymptote. So we talked about that. X equals 0, x equals 0 there. We also have a horizontal asymptote, y equals 0. Okay, and that's y equals 0, horizontal asymptote. And then we also have a vertical asymptote at x equals negative 4, and we want to draw that in red. I like to draw our asymptotes in red. So we don't have any x-intercept. Oh yeah, we do have an x-intercept. We have an x-intercept of negative 1, 0. I forgot about that one. So negative 1, 0 is an x-intercept. Causes the numerator to be 0. Now how are we going to get from this asymptote to that one? We could either go down like this, or we could go up. So we just have to pick a value, like let's pick negative 2. If we replace x with negative 2, all right, so we're going to test some values, test values, to see if the graph is above or below the x-axis. So if we test x equals negative 2, well, r of negative 2 would be equal to negative 2 minus 1. All we really care about, or at negative 2 plus 1, all we really care about is whether the numerator or denominator is positive or negative. So we have negative 2 times negative 2 plus 4, and that's 2. So again, all we really care about is the numerator here. Negative 2 plus 1 is negative. And down here, negative 2 times positive 2 is also negative. So that's going to be a positive. So r of negative 2 is above the x-axis. So therefore, we have to get from asymptote to asymptote through the x-axis right there at negative 1. So that's that part. Now if we test out, let's say we test a value like negative 10. Okay, again, all we're caring really about is the sign. So if x is negative 10, the numerator is going to be negative. The factor in the denominator, both factors in the denominator are going to be negative. So we have negative divided by a positive, and that's a negative divided by a positive, so that's less than 0. So r of negative 10 is less than 0, which means the graph of the function is below. the x-axis. And you have to get from asymptote to asymptote. Okay, and then likewise, most likely we're going to be above the x-axis when x is equal to 1. So if you notice the function x plus 1 over x times x plus 4, those are all positive. If you get to the right of 0, meaning when x is to the right of 0, if x is positive, then positive divided by a positive times a positive, so it's going to be positive. Any number, for any real number x that is positive, the graph of the function is going to be in the first quadrant. So it has to go from asymptote to asymptote. And that is how you graph it. You can confirm that with Desmos, and you've identified the vertical asymptotes. You've identified, now let's look at one last thing. We have to look at the range. Okay, so the range is then, you can see, wow, the range is all real numbers. So it's a good thing we waited until we graphed, because even though we have a horizontal asymptote, y equals 0, the graph can cross a horizontal asymptote. That's okay. And it does in this case, so therefore there's no missing y values, and so the range is all real numbers. Okay, the range is all real numbers because every y coordinate is accounted for. There's no holes. If you look sideways, there's from negative infinity all the way, every y coordinate is accounted for. And that's it.